The average height of all students in the introductory statistics class, both males and females, is 167 centimeters. Nevertheless, if you chose a sample of 30 students and calculate their average height, you most likely will not get 167 centimeters exactly. Which of the following terms describes the expected difference between sample means and their corresponding population means? Okay, so I'm going to talk a little bit about what it is that's being discussed here. Now, the idea is that sample means are not necessarily going to agree with the population means. So to illustrate this point, let me give a small example. I'm not going to look at an entire classroom of people. I'll just look at a small group. I'm going to make my population really small. So let's say I have a population where everybody is 167 centimeters. So here's the first person, that's their height. They're 167 centimeters. Here's the second person, they also are 167. The third person and the fourth person. Okay, let's say my population is only 4 people. It's a really small population. Now, if I took a sample from this population where the average in the population is, you can see that the average of all of those people is going to be 167 because they're all the exact same height. If I took a sample of just one of them, let's say that this one here is who I sampled. So in my sample, I have only this to measure. One person who is 167 centimeters. Well, the average in my sample is equals to 167 centimeters, just like in my population, the average is also 167 centimeters. That happens here very easily because every member of the population has the exact same height. But in reality, that's not going to happen very often. In reality, you'll probably get a population that's going to look something like this. Maybe somebody is just a little bit smaller than the average, so 165, and then there's another person who's a little bit smaller. Here's somebody who's a little bit larger than the average, and another person who's even larger. So here I've got 4 individuals, and if you add up these 4 numbers and you divide by 4, you're going to find that the average here in this small population is still 167. But you can see that now if you took a sample of any one of these individuals, your average is not going to be 167 because it's not possible. There is no one person who even has that value. So samples don't always agree with the populations. Sample means, or the average that you get from a sample, doesn't always show you what the average is going to be in the population. This is not a mistake. It's not an error that you've made in terms of how you've conducted your research. It's just a problem with taking samples and expecting them to perfectly reflect the population. This is called sampling error. So C is our error here, or sorry, C is our answer here. Now these other terms, some of them might not even be proper terms. For example, inferential and parametric error. I don't think that those are ever even mentioned in your course, and I'm not sure that they define or that they have proper definitions in statistics. Statistical error is just general error in doing research. So one type of statistical error is sampling error. There are other types of statistical errors. But again, these are not covered in your course, so I'm not going to go through that, or at least they're not covered right now. The only type of error that you're taught early on in the book like this is sampling error. Sampling error is the expected difference between sample means and their corresponding population means.